What if your robot assistant could not only pick up your coffee cup, but also feel its warmth, pressure, and even texture just like you do? It's not science fiction anymore. We're diving into the science behind a breakthrough in robot touch perception that's inching machines closer to human-like sensation. I'm Ben. This is Physics to Bust. Researchers at Uppsala University and Karolinska Institute in Sweden have developed a new tactile sensor system that allows robots to detect touch with resolution and sensitivity approaching that of human skin. These sensors don't just detect contact. They interpret directional force, pressure, and even texture. This technology combines soft materials, highly flexible electronics, and biologically inspired signal processing to let robots feel in a way we've never seen before. The sensor is made of multi-layered flexible material embedded with microelectrodes in a grid. When pressure is applied to the surface, it compresses sections of the sensor, changing the electrical resistance and capacitance in those areas. We'll look more into the physics of this next, but first, if you like this video, you'd probably like this book. I've got a link in the description below. I do get a small commission, but it wouldn't cost you any extra. Now let's dive into the physics of these sensors. The core mechanism of these sensors is based on the piezoelectric effect and capacitance sensing. Here's how. When you press on the sensor, you're changing the distance between two conductive plates within the material. That changes the capacitance because capacitance is inversely related to the distance between the two plates. Capacitance increases when the distance between the two plates decreases. The system uses these variations in capacitance to create voltage signals that correlate with the amount and location of pressure, very similar to how neurons convert pressure into electrical impulses in your skin. In some layers, piezoelectric material generate a charge when deformed. That gives an additional layer of feedback, not just how much force, but how fast it was applied. Just like human reflexes react differently to a tap versus a punch. But what really sets this tech apart from its competitors is its ability to detect shear forces, the sideways movements across the skin. This mimics how your fingertips sense texture by movement, and is absolutely necessary in order for a robot to detect exactly how much grip they need to apply in order to pick up something fragile like an egg. This breakthrough could enable robots to perform a much wider variety of tasks. It could enable safer robot-assisted surgeries, true feedback on prosthetics, or robots working delicately in homes or disaster zones. A robot that can feel like humans do is much less likely to crush, break, or mishandle an object like an egg, or people. The team didn't just design and build a good sensor, they modeled it after real biological systems. Like human skin, the robot sensor has both fast-adapting and slow-adapting zones, which respond differently to continuous pressure and quick taps. This enables more realistic perception and faster neural-like response times. The sensors still require careful calibration and are very sensitive to temperature, material fatigue, and signal noise in messy environments, so they're not ready to be the outermost layer on just any robot yet. But once they integrate AI and figure out better signal filtering, they'll be extremely close. Pair this with neural networks, and suddenly you have machines that can not only adapt to current situations, but also capable of learning touch patterns, like humans learn handwriting. This is a cornerstone for truly adaptive robotics, and it's powered by deep physics, clever engineering, and a whole lot of biology-inspired thinking. Would you trust a robot to touch, feel, and react just like a human? Let me know your thoughts in the comments below. For more space science and news updates, remember to like and subscribe, and remember, keep asking questions. I'll see you on the next video.